So let me first motivate the title. I think, and we saw that already in the morning, that Kuhn is really at the beginning of the larger discussion in philosophy and history of science on conceptual change. So everyone should be familiar with it, but my impression is that the potential of Kuhn's story about conceptual change has not been fully exploited and is really, I think, underestimated. And I will show you that in my own example, because in this talk, I discovered something new for me about this. And you know, I've read the book, The Structure of Scientific Revolutions, even twice, I think, but I still discover new stuff. Anyway, so I'm going to talk about Kuhn's Aristotle experience. This is just the introduction. Many of you will be familiar with it, and I'll do it very quickly. And then I speak about Kuhn's theory of empirical kind concepts, then about conceptual change, and then the question, why is there conceptual change? What are the reasons of conceptual change? And finally, I come to the conclusion. So let's start with Kuhn's Aristotle experience, and that is somewhat interesting to set the context of Kuhn's theory. Why did Kuhn investigate this topic? And the context is this. It's again a didactic context in the history of science, education, and we'll see that there are naturally in Kuhn's work and also in the social circumstances many natural interfaces to the teaching of physics and the other sciences. So that's interesting, and of course should make the bridge easier, you know, what this little conference is trying to bridge. So the context is this: James Conant was president at Harvard, a very influential man in the United States, and he thought that in the nuclear age all students should understand the basics of science for democracy. This is a very important input here. It's really Conant's persuasion that in a democracy after the explosion of the atomic bombs, people should be somewhat familiar with science. And he thought that a course in history of science would be the best means for that purpose, and that course then consisting of case studies. And one of the case studies that he envisioned was the genesis of classical mechanics. And this case study was assigned to a young theoretical gifted student, theoretical physics student, graduate student Thomas Kuhn, and that happened in 1947. So ambitious student Thomas Kuhn had to answer the question, how much and what physics did Galileo inherit from his predecessors? So what is, in order to see what is the innovation that Galileo produced. Now, the physics before Galileo that was well known is the Aristotelian tradition, mainly based on, of course, Aristotle's physics. And then young Thomas Kuhn started to read the physics in English. He didn't know any Greek, of course, and he found it extremely bad. What a bad book, he thought. What a bad physics. What a bad physicist Aristotle is. And that was strange. He knew enough about the context, given the tradition built on that book and given Aristotle's talents as shown, for instance, in his logic and in many, many, many other fields. I mean, Aristotle covered really almost everything one could write and think about it in his times. And then Kuhn suddenly discovered that some key terms in the text may have meanings different from ours. So we have the same word, but they have apparently different meanings in Aristotle's text. And with altered meanings, the text made much more sense, and a very different worldview emerged, a very different physics, of course, that Aristotle was defending or developing. All right, so I give you just one very quick example. The motion, of course, Kuhn read motion. In Greek, it's kinesis, and it's translated as motion, and it's usually also in German and other languages just translated with the common term that we use today. And for us, of course, motion is motion in space. But for Aristotle, motion is something else. It's much, much wider. Motion is qualitative change or quantitative change, or to come about or to vanish, or as a special case, locomotion, motion in space. And clearly the concept of motion has drastically changed in the transition from Aristotelian to modern physics. It's really a drastic narrowing to just locomotion, but this is not seen in the text immediately. Now, such transition comes usually or often with an equally drastic change of the worldview or the physics worldview or whatever it is, or biology, chemistry, whatever it is. And these are then called scientific revolutions. That's a term that was already in use, but Kuhn gave it a new coinage, but I'm not going to talk about that. And the lesson first is apparently that scientific concepts admit of such drastic changes in meaning, and that these changes in meaning do have important consequences. So, and this is when Kuhn started to develop his program for his whole intellectual life till the end, explicitly only from the 1970s on, develop a theory of meaning for empirical concepts. There were already theories of meaning for empirical concepts, but they didn't suffice for what Kuhn wanted to do. Namely, they should have the following, this theory should have the following properties. It mirrors the actual practice of scientists, the practice of scientists when they deal with concepts. And it should make meaning change, and also, of course, the complementary thing, meaning stability, intelligible. Why is it that meanings changes, and how meanings change, and how is it that meaning is stable in the transmission sometimes from generation to generation? And now this is again an interface with the science educators. Kuhn's strategy was investigate how concepts are learned and used in science. This is, of course, not always the case in philosophy, that people investigate the learning process leading to something. But very often philosophers just say they're analyzing ideas. The question is, of course, for any historian, where do these ideas come from? Where do you get it? How was it transmitted? Is that the right procedure? Are you really getting at the core? And so on and so forth. I'm not defending that here. I'm just telling you, Kuhn investigated how concepts are learned and used in science. And from that, he tried to develop his theory of meaning. And the first obstacle one has to remove, and I guess also possibly some people in the audience, you have to remove that first. Don't ask, when you ask for the meaning of concepts, don't ask for definitions. Because, and this is an empirical fact, definitions in empirical science play a negligible role. If you really look how in science education concepts are learned, possibly not at high school level, but if you really look at the education then of scientists, then definitions really play a negligible role. And this is something that Kuhn had realized because he was a physicist himself, and then in his historical studies. Okay, so this is the introduction. This is why Kuhn investigated that. He wanted to sort of, work with his own experience and try to learn something about science. And then he developed and concentrated on these empirical kind concepts. And I'm going to reconstruct now and amend a little the theory of empirical kind concepts in 10 steps. So the first step in my development of this theory is that both in everyday life and in science, kind concepts are introduced by repeated exposure of exemplars. I'm not saying that this is the very only way, but this is a very important one. And also you see here, we've got another interface to science education, because that may also play a role in science education at various levels, also high school level. So kind concepts are introduced by repeated exposure to examples. This is not something revolutionary at Kuhn's time. And Kuhn's example, this is a little from the early 70s, is that a child learns the concept of goose, swan, and duck in the zoo. And how does this work? Well, the teacher points at birds and commands, this is a swan, this is a duck and not a swan, this is a goose, etc. And the pupil applies this and is, when necessary, then corrected. And after a while, the pupil is able to correctly classify all waterfowl she encounters and knows then, so to speak, the concepts of swan, duck, and goose. Now, the theoretical terms in science, this is now a larger step that I cannot develop in detail. The theoretical terms in science, like, for instance, force, mass, selective pressure, pecking order, they are introduced similarly, but because we cannot point at these objects, because they are theoretical terms, the exemplars are in this case scientific situations in which the relevant concept plays a role. For instance, force. Then you point to the situations in which the term force is used, and then you show how it's used in different situations. Okay, but this needs, of course, more elaboration, which I can't do for time reasons here. So that was the first step. So ostension to objects or situations plays a major role in Kuhn's view. Second, I mentioned it already, definitions play a very minor, if any, role in this kinds of concept learning, and you will later see there's a theoretical reasons for that. This is not just, a fancy idea what concepts could be, but it's really something which you can later understand. The third step is an analysis of what the pupil is learning. Namely, the theory is here, the pupil learns to see the relevant similarities between like cases and the relevant dissimilarities between unequal cases. So for instance, in the case of duck, geese, and swan, you see the similarities between all different specimens of ducks and their dissimilarity to the swans, etc. So you learn a network of similarity and dissimilarities between these different cases. And this enables them to use the pupil to use the concept correctly. That's not an absolute sense of correct, but it is used as it is used in the respective language community. So you learn the language of your language community, and correct means you use the concept then in the same way as the other members of the language community use the terms. So fourth observation is then, or theory rather, the meaning of a kind concept, what is usually called its intension, consists in its position in the pertinent part of the lexicon of empirical concepts. Okay, so the point is that this term is not learned in isolation, but it's learned together with other terms like duck in context of goose and swans. And then the meaning can be reconstructed as being the position in the pertinent part of the lexicon of empirical concepts, I'll show you in a second, which is a consequence of the pertinent similarity and dissimilarity relations. So at the bottom are the similarity and dissimilarity relation, and they build up then a taxonomy of concepts, a lexicon of concepts. For example, this is what we learn. This is the part of the lexicon of this example. You learn that waterfowl in this particular case, ducks, geese, and swan, and you see the similarities and the dissimilarities. And this is the whole portion of the lexicon that you learn with that learning experience that I sketched. So, this is a consequence now of what I just said. There is a certain meaning holism involved. This is nothing mystical. Sometimes, or very often, when people speak about holism, and if you ask, what is it exactly, what's going on, then you don't understand what's going on. Here it is very clear. It means that the relevant concepts are learned together, as I showed in the example, and they get their meaning by their position in the lexicon. And this is very important because the meaning of duck in this picture is also co-constituted by its difference to the meaning of goose and swan, and so on. So these concepts are interlocked, and therefore one can say it's not a single concept that has meaning, but it has the meaning only in the context of these neighboring concepts. And therefore one can say there is a sort of meaning holism involved, but this is nothing mystical or very strange. It's just a consequence of this sort of learning process. So this learning process, this is now an analysis under which circumstances this sort of learning process can be successful. And this learning process, according to the theory, can only work unproblematically if there is no overlap between the extensions of the pertinent concepts. And that means the following: if this is duck, goose, and swan, then there must be no overlap, because then it's easy to distinguish them by their similarity and dissimilarity relations. Whereas if you have a situation like this with an overlap of different concepts, then it's very difficult, it's more difficult, perhaps impossible, to learn these concepts simply by pointing. It's not absolutely impossible, but it's much more complicated. And the usual thing, especially in the sciences, is that we have this situation, and a good classification does that job on this kind of distribution of extensions. Now, this postulate, however, is not really problematic. It looks like a very heavy presupposition, but it's not really problematic, because in any taxonomy that we use in the sciences, concepts at the same level must not overlap. You can find that already in very early 200, 300 years old ideas when people spoke about classification and taxonomy. Of course, the extensions must not overlap, otherwise the whole taxonomy doesn't really work. And Kuhn gives this a name, the no overlap principle. But as I said, you find it, for instance, if you go to Kant in the logic, you find it there, the no overlap principle, when Kant speaks about taxonomy. So it's an old thing, it's nothing revolutionary. So now comes a very important, and I think in much of the literature not really appreciated point, which I think is one of the best points in Kuhn's theory of concept. All members of a language community classify the objects in the domain in the same way. So for instance, the ducks, goose, and swans. But their means of classification may be different. Now, means of classification, what is this? Now, I'll give you an illustration and then you see immediately the point. I may identify swans in contrast to ducks and geese by their long necks. So whenever I look at these waterfowl, I identify the swan by its long neck. But you may identify them by their peculiar beaks. You concentrate on something else. So you come to the same classification of ducks, goose, and swan as I, but we use different means, namely different criteria, how we pick out swans and distinguish them from ducks. And this is a very general thing. We can do that. There's this old joke, Kuhn mentions it once, that a little Bobby stands in front of a picture of Adam and Eve, and then somebody asks him, who is Adam and who is Eve? And then little Bobby says, I don't know, because they're naked, they don't have any clothes on. And that shows exactly the thing that you may identify. Well, today it's more difficult than in Kuhn's times to differentiate between man and woman concerning and different sexes. I don't know how many there are, just by their clothes. But it's one way of trying to classify, and there are many ways. And the fact is then a very important fact that has not been really, I think, deeply appreciated. Despite homogeneity concerning language use in the community, when language functions unproblematically, same classifications, individuals may differ from one another regarding the criteria they use in identifying members of the kind. So theoretically, it may be that we speak the same language, classify objects exactly identically, but you use completely different criteria from the criteria I use. And we never, usually unless we speak about language, but only speak about things, when we stay on the object level, we never realize that because we have completely unproblematic communication. So usually this inhomogeneity among the members of the community is invisible. Unless, as I said, when we reflect and then say, wait a minute, how do you pick out swans and how do I pick out? And then you say, oh, funny, you do that differently from me. But you don't realize that when you simply talk about these animals, because there is no problem with the classification, you classified exactly the same way as I. So eighth point, and this is also interesting about the dynamics of language. The more is learned about the members of a kind, the more criteria are available for individual speakers in the respective community to identify those members. Okay, so you observe the swans and you start with, by their long neck, and then you identify their feet are very different from duck's feet, and this and that is different. And then you learn more and more, and others may learn more and more and more. So there may be inhomogeneity of the criteria by which you pick out the members of one concept extension. That may get more and more diverse without anyone noticing. Because unless you speak about language, you have to go to the meta level, you speak about the objects, and then everyone picks out the same objects under the same concepts. All right. And this is then language may become more and more adapted to the specific features of the kinds in question, because that's an empirical process, right? You discover these different properties of swans by which you can identify them. That's presented by the world to you, and you just see, oh yeah, I pick out this is a swan, and then you find out, oh, it has this and these and these and these and these unique features by which I can distinguish them, swans, from ducks and goose. Right? Also from cars, but that's not the question here, because you want to distinguish them from other birds. Now, this has an important consequence. These two things are very important. There is a group level or language community level at which they have the same lexical structure, but the individuals speaking the same language, having no communication problems, may use very different criteria how they pick out the individual items that fall under a concept. Now, this explains why empirical kind concepts that are homogeneously used in a language community can typically not be defined without forcing conventions. So we have a concept like goose or duck or whatever it is, and there's no disagreement and no problems when people communicate. But when you ask them define the term, then that may be impossible without forcing conventions, meaning that you cannot get that out of the normal use of language. And this is because there are many criteria used by different speakers to identify the reference of a concept, right? You use the long neck, I use something else. Which one belongs to the definition? Well, that's not clear. Criteria cannot be sorted naturally without forcing conventions into those that hold in virtue of the meaning of the concept. That was earlier, it was called essential properties of the thing. They make the thing what it is, right? So we cannot naturally pick out those criteria which belong to the essence of the thing, the essence of ducks or swans, in contrast to those that happen to hold only empirically, accidental properties, right? So the point is, if you look at this language learning process, and you look then and see the diversity of different speakers who use different criteria in order to pick out an exemplar of a certain concept, then you see there is no natural grouping of what property belongs to the definition and which property does not belong to the definition. This was already, or something similar was already, of course, discussed in antiquity. You know, when the question is, what is a human being? And then one was, of course, it's the animal that has the logos, and that's a complicated term. And the alternative was, that's the animal that has earlobes, because it happens to be that only humans have earlobes. And of course, you can pick out, if you have an animal in front of you and you look, does it have earlobes? Fine, wonderful, it's a human being, right? But people thought that's not the essential property of human beings. The problem being, how do you really distinguish methodologically or methodically, how do you distinguish between these essential properties that figure in a definition and those that are unessential? How do you distinguish these two? And I think there are no real criteria. Just look, just take any sort of concept that you've learned, define what a book is and what the essential properties are, define what a car is, and you will have problems and experience that. That's, of course, not an invention by Kuhn, but this is just falls out of that theory, so to speak. And as I said, for a definition of a concept, a set of necessary and together sufficient criteria for concept application is needed, flowing from the meaning of concepts. And if you appreciate and accept this theory of concept, then you see that that doesn't flow out naturally out of the meaning, because the meaning is just the position in the lexical structure, and that doesn't prejudge what sort of criteria can be used by the language, by the members of the language community. And finally, this is also underappreciated, I think, the coexistence of different criteria of concept application that are illustrated, you know, different speakers, but it may also be the same speaker, embodies empirical knowledge claims about the pertinent domain, right? And this is simply because if I know I can pick out by the long neck the goose, and you know you can pick out by a special form of the foot, then it's quite clear that creatures with a long neck have a special form of the foot, and that's an empirical statement, and that's embodied in the coexistence of these different criteria of concept application. And this has important consequences now also for language change, which is not visible here. If in a new situation such knowledge claims are violated, linguistic confusion may emerge, and not just false statements. So there's a difference between linguistic confusion, you know, not when I contradict you, you say what you say is false, but when I say, what the hell are you talking about? I don't know what you are saying, right? And this is linguistic confusion. And the earliest example I know of was that in ancient Egypt, there were two criteria for the direction north, interchangeably used in the older Egypt. Namely, an astronomical one, you know, you looked at the sun and whatnot and stars, and then, you know, north is this. And then you could also use downstream, because the Nile happens to go in this north direction, and that the coexistence of these criteria worked wonderfully. Of course, it embodies the empirical knowledge that the Nile goes north all the time. Well, they got in trouble when I have read that talk before. Okay, yes, here we go. All right. And later, a region in the south was discovered in which the Nile was flowing south. And then they really had problem, because then applying the two criteria for north gave opposing results. And that resulted in linguistic confusion, and that was already recorded in the 16th century before Christ. So this is an experience that people have made. If you use different criteria under normal circumstances, everything is fine. But if you come into a new situation, you may experience breakdown of clear communication, linguistic confusion, and all sorts of problems. And then you have to think how to heal that. Okay. So this is the basic. And now from this theory of meaning of concepts, we can approach the topic of conceptual change. And as I said, similarity and dissimilarity relations are constitutive of concept meanings in this quasi-holistic way. And then the point is, when such relations change, the taxonomy, this is the structure of the lexicon, may change. So this is conceptual change in this Kuhnian picture. All right. So I give you the example. It was mentioned already today, and I can quickly go through it. So the geocentric versus the heliocentric planetary system. The geocentric system, the similarity is the similarity of the planets, and the planets included the sun, the moon also, as opposed to the fixed stars. That's the partially irregular motion of the planets relative to the fixed stars. So that was the similarity class of the planets. And here, this is the classification here. So the celestial bodies, they are the fixed stars and the planets. The fixed stars are simply fixed in the sense of their relative fixity. And then the planets, the sun, the moon, the Mercury, and so on, Saturn, they move irregularly relative to the fixed stars. And you see here the sun and the moon are in the geocentric system, planets. And the heliocentric planetary system, this is also not new to you. The similarity of planets as opposed to fixed stars and satellites is given by their true motion around the sun. So you have a very, very different criteria. You don't look at the apparent motion, but you say the true motion around the sun. This is what makes all the planets similar. And these are other planets than the earlier planets. And the similarity of satellites, which is a new category, as opposed to fixed star and planets, if given by their true motion around a planet. So this shows what the satellites are. And that led, of course, to a massive conceptual change, although the term planet, the word planet, was retained. And you all know that. Now we have celestial bodies, but we have three different kinds: fixed stars, planets, and satellites. And then you see that the fundamental changes. First of all, satellites is a new category. The moon is there, and then Io and other moons of Jupiter first were discovered. And then the fixed stars, something completely strange, invaded that class, namely the sun belongs suddenly to the fixed stars. And here, the planets, suddenly the Earth was a part of it. The moon was out there, the sun moved there, the moon moved there, and we have a very different conceptual structure. And therefore, the meaning, of course, of planet changed drastically, as seen in this change of the extension, where the sun and moon are removed and the Earth moved in. Now, the next question I want to ask, so this is also clear, once you know what meaning is, then you know it depends on the lexical structure. What is meaning change? It's change of lexical structure. And the next question is, why should I change, or anyone change, the lexical structure? What could be a reason for that? And there are two main possibilities. And this is now stuff that in that clarity I've never written up before, because it just came to my mind when I started working on this paper here. So the first thing is, the first discovery is, the first possibility is that you discover that the current similarity-dissimilarity relations don't hold. You know, you had the conviction that there are these similarity relations, and then you suddenly realize, wait a minute, that's not right. That's not true. And of course, the example is the geocentric system, that the similarity among the sun, the moon, and the other planets was seen then as superficial and only apparent. There's no fundamental dissimilarity of the sun with a fixed star. So people said, wait a minute, therefore we've got to regroup everything. And that led then, of course, to the new system. In fact, the sun is similar to the fixed stars, the Earth is similar to Mercury, Venus, etc., and the moon is similar to the recently discovered satellites of Jupiter. So you just rearranged everything according to similarity and dissimilarity. And that's the main and less controversial aspect of Kuhn's theory here, when the dissimilarity and similarity relations change, things become reshuffled in different categories. Clearly, this results in meaning change. But the second thing is here that you discover objects, that objects exist that do not fit the current taxonomy, so to speak, anomalous objects. And I give you examples, I can describe it first in different ways. Such objects can equivalently be described, given the current taxonomy, can be described as being conceptually impossible. Right? You say you discover something that can't exist, but it's there. Yeah. Oh, wow, what's happening? They fall into the empty space between current concept extensions. I told you the context extensions must be separated from each other. And if you find an object that's in between, you say, wait a minute, that doesn't belong there, can't exist. Conceptually impossible, but it's there. Or finally, you can describe it as such, combining criteria for concept application from mutually distinct sets. That's the same thing. I explain it to you. Abstract example. Concept A, you have valid criteria A1 to AN. Different speakers use different criteria. Then you have concept B, valid criteria B1 to BM, with all AI different from the B's. So you have all for your swans and all for your ducks, and they are mutually exclusive. And now you discover an object with the properties A1, A2, and B1 and B2. So that's conceptually impossible. It's in the empty space, and it's just the criteria are crossing the boundaries of the object extensions. And I give you a concrete example that I'm not making this up, viruses. So the older taxonomy of infectious agents was living matter versus dead matter. And that held until the early parts of the 20th century. This is quite clear. There's living matter and there is dead matter, and we had a cellular theory of life and so on. So the lexicon of infectious agents around 1900, this was already 30 years of flourishing bacteriology. We have infectious agents, living, cellular, and there are bacteria newly discovered, and protozoa, and fungi, and parasites mainly. And then we have potentially at least non-living infectious agents, chemical substances, in other words, some sort of toxins, right? This was the idea around 1900, and almost everything could be nicely put into this scheme. Now, viruses had some properties of living matter. For instance, the reproduction in a host organism, right? Like a bacterium. Or they had mutations, like bacteria and also other living beings. And they had some properties of dead matter. For instance, smaller than any organism, they couldn't be identified under the microscope in the beginning, and crystallizability, which is not a property at that time of living beings. So they were just, not fitting into that scheme at all. And this was then the changed lexicon of infectious agents. This is the old stuff here. It's all there. But between living and non-living, it seemed to be logically impossible to have an additional category. But this is where the viruses came in, because they filled that space with having properties of living and properties of non-living, just a new class of biological entities. So, all right. Now, the reaction to the invalidation of similarity and dissimilarity relations, or to anomalous objects, which is essentially the same thing, is this. You must rework the taxonomy, right? You find these objects that don't fit, and then you've got to rework the taxonomy, because the taxonomy must obey the no overlap principle, and you must rework it somehow. And I showed you the examples already. Regrouping of objects in the taxonomy. That's, of course, all the examples so far did. And that goes together with the elimination of certain classes and the introduction of new classes. I didn't show you an example of the elimination of certain classes, but the introduction of new classes, but this elimination also takes place. Now, this is now something new to which I'm coming, at least for me. In the example presented so far, the extensions of certain concepts in the lexicon change due to regrouping of objects, and correspondingly, their meaning changes. These are the things which are rather easy to grasp and understand within the Kuhnian framework. But there are other cases which I thought and was pretty insecure, namely the concept, the situation, there are the cases in which concept extensions remain unchanged, but are shifted in the lexicon such that its structure changes. And there was always this example that Kuhn used, that he said, in the transition from classical mechanics to a relativistic theory, special relativity, the meaning of mass changes, because in the first case, mass is constant, and in the second case, meaning is mass dependent. Now, the point what I had really my trouble always was, well, that's of course right what you're saying, but how do I know that the meaning of the concept changes? Isn't it just that the property of mass changes, right? But it's not that the meaning changes. And Kuhn stated it's the meaning change there, and I was said, and of course many critics also noted that, look, you don't have an argument that there is meaning change, right? Now the point, and only now I've worked that out, the point is of course dependent what sort of theory of meaning you have, right? And if you now apply Kuhn's theory of meaning to this particular case, then you'll see it immediately. So take the example mass and shape in classical mechanics and in special relativity. Now, if you look at classical mechanics, then it's quite clear. We have solid bodies and they have properties. And there are properties, really constant properties, you know, inherent, so to speak, in the solid body, and there are variable properties. And the mass of a solid body and its shape, unless you press it really badly, are constant properties. And then we have other variable properties in classical mechanics: the position, the velocity, the weight, depending whether you put the thing on the moon, on Earth, and the energy, and so on. So you have variable properties and you have constant properties. And it's very important that the mass, for instance, by being conserved, is something that is on the constant side, and this is on the variable side. Now, if you look at special relativity, things change. And it's really a different classification then, because we have now constant property, we only have the rest mass. I'm not talking about charges at the moment. So the rest mass, position, velocity are still the same, but you know, in relativity, the shape of the object changes, and of course its mass changes, depending on the inertial system from where you look. So you have a regrouping here and the introduction of a new term here, a new thing, rest mass, didn't exist in the old system. And then you have the mass, the actual mass of a particle, and that becomes a variable property. So you see exactly that in the Kuhnian framework of meaning, it's quite clear, although there is no change in the extension of the term mass, the meaning changes because the classification of that concept is now here under variable properties in contrast to the constant properties. All right. So I come to the summary. This was, as I said, this was new to myself because I had always struggled with this case, but never thought it through. And it's absolutely clear once you really put this theory of meaning that Kuhn developed only much later than 62, only in the 90s, 80s and 90s, then you see Kuhn is absolutely consistent in saying, yes, of course, meaning changes under this theory of meaning. So if you have a different theory of meaning, you may get a different result. Okay, now here's my summary. The meaning of an empirical kind term consists in its position of the respective lexicon, right? And there's also this sort of holism inbuilt and the similarity relations and so on and so forth. The lexicon is a property of the language community, and property in both senses. It's a feature of this language community. It's also they own it, right? It's their property. And if you ask where, so to speak, is the structure of the lexicon, you got to go to the community level, right, and not to the individuals. Individuals, members of that language community, operationalize this structure by individually differing criteria for concept application, right? At least they have the possibility, and in many empirical cases that is the case. I also have empirical cases for that. Therefore, that what is common in the language community is taken in a very individualistic way to the individual level. And again, this is not visible in normal communication. You only get at that when you speak about language and analyze what people are doing. And finally, conceptual change is a change of the structure of the respective lexicon. Structure of the lexicon being the relationship between the different concepts in the lexicon. And finally, conceptual change has as a cause or reason, whatever you want to describe it, results from the untenability of some of the hitherto accepted similarity and dissimilarity relations. So at the deepest level, of language is concerning that part of language are the similarity and dissimilarity relations. And when they change, the lexicon changes, and then we get conceptual change, and we get this confusion and communication problems and all sorts of things, and possibly a scientific revolution. Thank you very much.